All right, I also want to go ahead and review the chapter 3 because that is our agenda for today is review the chapter 3 in here. Okay. Um, chapter 3, this is the finance chapter, right? And if you go through like the some of the video we have last week, we actually reviewed quite a bit of the previous chapter 2 on chapter 3 already. Okay. All right, so 3.1, we're gonna convert this one into percentage, right? So how do you convert it into percentage? You multiply 100%, and then we move for 2 digits, and then write down the denominator 100 as this percentage. Okay, so you basically multiply this by 100, so move for 2 digits to the right, so that will be 0.58. All right, so another one is if you want to convert this one into decimal point, 0.58% is 0.58 divided by 100, right? So you will need to move 2 digits to the left. So that will be giving you the same number, okay? Number 2, using the formula to calculate the simple interest. So this is a simple interest formula, okay? So how do you find the T? Well, I have an I here is 175, right? And P here is 7,000. All right, R here, I will have to convert it into decimal point. So that's 0.05, right? That's 5 divided by 100. So I have an R here is 0.05 and then times T. Okay, so how do you calculate this one right here? Well, you can 2 decimal point cancel out, right? So that's 350. 2 decimal point cancel out, okay? Or you can use a calculator. So my T here is 175 divided by 350, and that actually is 0.5. Okay, you can double check. 175 divided by 350, that's 0.5, right? Yeah. All right, so that's 0.5 years, so that's a half year. Okay, so what does that mean? That means if you deposit $7,000 into a bank that earn 5% interest rate for half a year, right? You will get $175 just for the interest only. Okay, just for the interest alone, you can get $175. So if we're giving you this formula, it's pretty straightforward. You just plug it in and do the calculation. Okay. This one is using this formula for the indicate quantity. So that means you want to find the total amount A, right? So what is the total amount A in here? Well, I want to find the A, so I'll have a P here is 4500. Okay, 1 plus R, I want to convert the R into decimal point. So that's 0.08 times the T here is 2, right? All right, so that should be pretty straightforward to calculate this one right here. You can go ahead and calculate inside the parentheses first. So that's 1 plus 0.08 times 2, that's 1.16. Okay, so I will just use 1.16 times 4,500, so that's 5220, $5,220. Okay, so that should be pretty straightforward. If you do the calculation in here. All right, let me go ahead and double check the calculation. 8%, 0.08 times 2 is 1.62 times 4,500. Yeah, that's right. Okay, I think the book answer is a little bit incorrect in here, but this is correct answer. Just double check. All right. Okay, number 4, a loan of this much was repaid at the end of the 14th month. What size of repayment check? That means the principal and interest was written. If 10.7% annual rate of the interest was charged, okay, around to 2 decimal point in here, So this one, it didn't say the compound. So it didn't say this is a compound. So we're gonna think this is a simple interest. Okay, the simple interest in here. All right, so simple interest, one thing is we have to convert this T into year. 14 months, how many years will that be? Okay, this is 14. Okay, if you want to not really doing that, we can just using 14 months. 1 year is 12 months, right? So this will be 14 over 12 year. Months and month cancel out. Okay, so that is another way you can do the calculation, and you can simplify this one. This is 7 over 6. So that's for the T, right? And if this is a loan, so that means this is a principal, was repaid at the end of the 14 months. How much you have to write? Okay, so that means include principal and the interest. We're gonna use the formula we have earlier. This is the repayment. Okay, we have A is equal to P times 1 plus RT. This is for the simple interest. All right, so we have a 17670. 1 plus R. R is this much. So we're gonna convert it into decimal point. Times T is 7 over 6. Okay, and I can just plug this whole thing into calculator. We usually say do not run until the end, right? So I can put this whole thing into calculator all together. Okay, times the parentheses. 1 plus 0.107 times 7 divided by 6. And then we're gonna run to 2 decimal point. We usually the value we run to 2 decimal point in here, right? So if you run to 2 decimal point, the third digit is 5. You will need to run up. Okay, so this will be run to 81. Okay, 0.81. So we have a 19875.81. Okay, so that will be and that is dollars. That will be the end of the paycheck. You will need to write this much. If you borrow this much for 14 months with this interest rate, you're gonna have to pay this much, which include the principal and the interest rate and the interest. Okay. Any questions? All right, number 5 is a minimum payment on the unpaid balance of $849.07. Assume the minimum payment on a credit card is either $30 or 2% on the unpaid balance. Okay, so what is the minimum payment in here? All right, so that is sometimes the credit card company, right? So you have this balance in here. So you're gonna go to compare the 2% of this balance is greater than 30 or not. Okay, if it's greater than 30, you say the minimum payment on a credit card is the greater value, greater of these two unpaid balance. So that means if 2% of this one is only $20, your minimum payment will be $30, right? But if 2% of this one is greater than $30, you will need to pay the greater one. Like I said, 2% of this one is $50, you will need to pay the $50 because it's the greater one. Okay, so we're gonna go ahead and calculate this one right here. 849.07 times 2% is 0.02, right? So we're gonna go ahead and calculate this one. So basically, you just have to understand what the question asked. All right, so this is only 16.98. Okay, so what's the minimum payment? The greater one of these two numbers, so that is $30, right? Because this one is less than $30, so you have to pay a bigger amount for these two. All right. Okay, number 6, use the continuous compound interest formula to find the indicate value. As I mentioned earlier, we have this chapter 3. I actually organize one page of the formula for you. Okay, so if you look at this one right here, you have a formula. And by the way, I posted this. I just put this folder in here tonight. My math lab review question. This is the one I'm using right now. So all the questions are posted right here, because in the past sometimes people ask me to send a question. So this is the one I am reviewing right now. If you look at this one right here, this is exactly the same number. Oh, hold on. I got a wrong one. Okay. I posted this one is a calculus. I will repost that. Okay, sorry about it. But I will post this in here. All right. I will fix this one later on. Okay, so the formula sheet right here, this is what I'm talking. The formula sheet right here, you have a chapter 3 formula sheet. Okay, so you also have a finance formula sheet. Okay, so this is very helpful. All this one is for chapter 3, the finance one. Okay, so you have a simple interest in here, or this has to be a parenthesis. Okay, and then you have a compound interest in formula, and then this is a continual compound interest in formula, and then the annual percentage year, future value, present value. Okay, so all the finance formulas are in here. You can actually print this page out and you can use on the test. Okay, so that is a really good deal that you can have a formula sheet for all the formulas for the test. So this one is a compound interest in continuous. So continuous, that means you cannot count how many times a year, right? So you're gonna using the base E. So that is the key here. All right. So we have a P A equal to P to the RT. So that is the continuous. This is the key word here. All right, this is the key word called continuous. All right, so when you see the continuous, this one you're using A equal to P times E to the RT. All right, so we have found the R. We have A is 13930 equal to P is 10300. E to the R here. Okay, we will need to convert it into E first. All right, so T is 60 divided by 12, so that is 5 years. All right, so you don't use the 60. If you use the 60, you're gonna assume you have 60 years, which is not. All right, so that's 5T. Okay, so in order to solve this one, I will need to divide by both sides by this number first. Okay, and then equal to E to the 5T. All right, so for this one right here, in order to solve this one, I will have to take a logarithm on both sides. Okay, and using a logarithm property, this will be 5T times ln E. Ln of the E is equal to 1, so this will be actually just 5T. Okay, so my T here will be just ln of divided by 5. Okay, and then I can plug this one into calculator to calculate this one. All right, so this is ln of 13930 divided by 10300. If you want, you can go ahead and calculate this one first and then divide it by 5. That make it easier. Okay, so T here will be all right, let's double check in here. 13930 1033 Okay, so this one we are giving you 0. If I round to 2 decimal point, it's 0.06. But let me see. Oh, okay, but we have to change it into percentage, right? Round to 3 decimal point is needed. So that means I will need to keep more decimal point, okay? Because I will need to keep 3 decimal point, and after you change it into percentage, so I will have to have a 6038. All right, and then we're gonna, oh, I'm sorry, this is a R, not a T, okay? I will just mess up. We have a 5 is T, T is equal to 5 already, so we're gonna find the R. So this should be the R, okay? Calculation is the same, but I just write down the wrong one. This is the R. Okay, because T is already equal to 5, we're gonna find the R, not trying to find the T in here, okay? All right, so R is equal to this much, right? And then if I want to find the percentage, I multiply 100%. So multiply by 100%, this is 6.038. So that way, I will satisfy for 3 decimal point. Okay, so that's 6.038. So now I have a 3 decimal point. Okay, so that is how we do this one in here. Any questions? All right, number 7, giving the annual interest rate and the compound period, find the I. Okay, if you have a 7.5 compound quarterly, so quarterly, that means M will equal to 4, right? So that's 4 quarter a year, so M is equal to 4. And how much is the I? Well, if you do not know I, as I mentioned earlier, you can come back to look at the formula sheet. Okay, look at this formula sheet in here. I is equal to R over M. Look at it, I is R over M in here. So I is R over M. My M here is 4. My R here is 7.5. Okay, so that's a compound per period, basically. All right, so if you go to divide by this one, this will give you 1.875%. All right, so that means you will compound. So if you have a 7.5 compound quarterly, basically it's 1.875% compound each month. Each month you're gonna get 1.875 of the interest. Okay. Some of them are pretty easy. Not everyone is a big calculation. All right. So given the rate for compound periods, find the R or the annual rate. Okay, so if you have a 0.75% per month, right? And what is the annual rate in here? Round to 3 decimal point. Okay, so this is I. And remember, we have I is equal to R over M. Okay, so how much is my R? My R, I will using M times I. So my M here is, my I here is 0.75. And then this is per month. So that means 12 months a year, right? R is the annual rate. R is the annual rate. I is just kind of like a per month. Okay, so we're gonna use this one multiplied by 12. All right, so that is 9%. Is 9% on the annual rate in here. Okay. All right, number 9, if 9,000 is invested as 4 or 3% compound continuously. Remember, when we say continuously, you will have to using the 1 with E, right? We have R equal to P times E to the RT. So when you see the compound continuous, this word, you use this formula. What is the amount after 4 years? Okay, so we have I equal to P is $9,000. times e to the RT. So R here is 0.03 times 4, right? And then this multiply together. If you want to calculate all at once, you will need a parenthesis for the exponent. Be very careful in here. You will need a parenthesis for the exponent. If you don't, you're gonna get a wrong answer. Okay. All right. So I'll show you what I mean in here. If you have a 9,000 times E, okay, second ln is the E, right? 0.03 times 4. Good thing is this one giving you the parenthesis automatically, so that's a good thing. All right, so we have this whole thing is 101. Okay, we have a 101 7.47, I think. Let's double check. Yes, because next digit is 1, so you round down. Okay, so that is the amount of the money after 4 years. But remember, you have to change the R into decimal point. So that's 0.03. Okay, any questions so far? Okay, number 10 is what is the annual percentage year APY for the money invested in a 4.36 compound monthly or 4.37 compound quarterly? That means if you have a choice, you want to go to deposit your money in a bank, right? And someone offer you 4.3% compound monthly, someone offer you 4.37% compound quarterly. Which one you will choose? All right, so we have an IPR formula in here. Okay, this is APY formula. Okay, so the APY or the effective rate is the annual rate compound n times per year. And this is compound continuously. So we're gonna find the APY, we're gonna use this formula. 1 plus R over M to the n power. Okay, I'm gonna go ahead and copy this one down. All right, so that is the APY formula in here. Okay, so I will go to calculate the A. If I convert this one into APY for A, okay, for A, my APY here will be 1 plus R. R here is 0.0436, right? And this is monthly, so it will be divided by 12, and then that's 12 power minus 1. So we're gonna go ahead and calculate this one to see how much will that be if you convert it into standard one. All right, so we have 1 plus 0.0436 divided by 12 to the power of 12, and then we minus 1. Okay, so we have a 0.0448. Okay, so that's my APY. If you want to convert it into percentage, right, so that's 4.448%. I want to 3 decimal point in here. So that's the A, okay? And then we're gonna go ahead and calculate the B, very similar one. APY in here is 1 plus, this is 4.37, so that's 0.0437. Quarterly, so M is 4. This quarterly M is 12, right? Okay, so we're gonna calculate this one and then compare them. Okay, so this is 0.4442. All right, if I multiply by 100%, that's 4.442. That's why I have to round to 3 decimal point in order to identify, right? Because these two are so close in here. So looks like this is still better, right? This is still a little bit higher in here, okay? Because the A here is 4.448, and the B here, APY here is 4.442. Okay, so if you have money to deposit, you will need to choose this one right here because it's giving you a little bit higher APY in here, the annual percentage year. All right, so plug it into formula into calculation. Okay, number 11. How long will it take money to double if you invest in a 4% or 5% compound continuously or 7% compound continuously? So what does that mean? Compound continuously, this we have A equal to P e to the RT. So what does double mean? Well, double, that means the amount will equal to the 2 times of the principal. So you don't really have to know the original amount in order to calculate this one, okay? Because if I have A compound 5%, my A is 2P, and then this is P, right? And the 5% is 0.05, and then this will be the T. And then you can see P and P cancel out. So I have a 2 equal to e to the 0.005 T. All right? In order to calculate this one, you will have to take a logarithm on both sides. Okay? And this whole thing, 0.05 T, will take it to the front, become the coefficient according to the logarithm property. And we know ln of the e is equal to 1. So that's 0.05 T equal to ln2, right? So my T here will be ln2 divided by 0.05. And we can go ahead and calculate this one right here. ln2, okay, we're gonna have to find ln2 and then divide by 0.05. So that's 13.86. Okay, let's see, round to 1 decimal point. So round to 1 decimal point, this will be estimated into 13.9. 13.9 year. Okay, so that is a 5%. A 7%, I can say that 7% here, if you look at this one right here, everything is similar. This will be just ln2 divided by 0.07, right? You can using this formula in here. Everything is the same. Okay. All right, so we have this one right here, ln2. Okay, and then divided by 0.07. So that will give you 9.9. So that's much faster, right? 9.9 year. Okay, so if you have a higher percent of interest rate, yeah, you can double your money much faster. If you 7% compound continuously, you have a little bit less than 10 years. If you have $1,000, your money gonna grow into 2,000 already. All right, and think if you have $1 million, you're gonna grow to 2 million, right? So that is very significant, right? So sometimes we have one saying said the rich people getting richer because they have money to work for them, right? If someone have $1 million in a bank, after 10 years with this interest rate, they already can double the money into 2 millions already. Okay, but if you are some people, have to borrow the credit card money, right? And we have a saying said the poor people getting poor, rich people getting richer because of that, right? If you think like you borrow the money from the bank, now you have to pay banker that much interest rate, okay? All right, number 12, find the I, find the N. I is the rate per period, and N is the number of the per periods for the annuity. So what is an annuity? Annuity, that means you will, like I said, some people want to save for the new car, or some people want to save for the retirement or college fund, whatever. When they were young, like in high school, right? So you make a deposit, like I said, $100 per month into an account for like 4 years. All right, and how much money will that grow? So this one, you have an equal payment, is called an annuity. So what is annuity? It's an equal payment. Equal payment. If you go to buy a new car, you don't have money, you borrow from the bank, right? You make a monthly payment to the bank. You borrow the annuity. Okay, so that is similar in here. A semi-annual deposit of $3,500 I make for 6 years into the annuity that pays 5.2% compound semi-annually. Okay, how much is the I? All right, if you really do not know what does the I mean in here, remember I said it earlier, we have a formula. Okay, so this is the annuity. Look at it, we have an ordinary annuity in here, and that is the present value and the future value in here. And that is I is the payment per period, okay? And how much is the I? It's the same thing. I is still equal to R over M. Even using this formula, I is still the same. I is still R over M, okay? So I is still R over M in here. And N is the MT. If you look at this formula in here, okay? And here is the MT, is the total number of the payment of deposit. Okay, so you have a 5.2% compound semi-annually, so that means the M is 2. All right, so this we are giving you 2.6%. All right, type it in an integer or decimal. So it didn't want you to type the percentages. So we will need to convert it into decimal point. So that's 0.026. Okay. All right, how much is the N? N is MT, right? And then we say M here is compound semi-annual, M is 2. And then T is 6 years. So this total number of the payment deposit, actually in this one is total deposit. You deposit twice a year, right? You deposit semi-annually. So you deposit 2 times a year for 6 years. So your total number of deposit is 12. Okay, so that is how you calculate this one in here. All right, so this is building the knowledge in order to calculate the one we have later. Okay. All right, let's look at some of this one right here. Using the future value formula to find the N, okay, how much is the N? If you have a payment, that means if you payment $200 into the bank account, interest rate is 0.03, future value is 8,000, right? So how many payments you have to do that in order to accumulate? Future value is 8,000, and you pay the $200 each time. Okay, so we already giving you the I, giving you the payment. I can just put it into the formula. So let's see what formula do we have. We have a future value, okay, in here, and a payment. So I can copy down this formula, and then I can find the N. Okay, so that is the formula I can use to calculate the N. And I'm going to show you another way to calculate this one using the calculator. Okay, for the annuity, the good news is you can use the calculator directly. So let's do the manual first, because I also want you to learn how to use the formula. Future value here is 8,000. All right, payment here is 200. We have everything here. I here is 0.03, right? So we have a 1 plus 0.03 to the n. N is unknown. N is the one we need to find out. Okay, so everything is known except the n. So we can calculate this one right here. And then we can kind of simplify a little bit. You have a 2, 0, 2, 0, both sides cancel out, right? And then I'm going to multiply both sides by 0.03. Actually, I can use 80 times 0.03 divided by 2. So that way I will have just 1.03 to the n minus 1 there. Okay, so I'm going to go ahead and calculate this whole thing first. All right, this whole thing you can calculate by hand, right? So that's 40, and 40 times this one is 120, and then you have a 2 decimal points, so that's 1.2. All right, and then you add a 1 on both sides, so you have a 1.03 to the n power equal to 2.2 actually. All right, and how do you calculate this one? We have to use the log because we have a different base, right? So I can use in the log. Okay, and this n we are taking to the front become the coefficient. All right, so how much is my n? My n here will be ln 2.2 divided by ln 0.1.03. Round up to the nearest integer as needed. Okay, so we're gonna go ahead and use the calculator to calculate this one. Okay, I didn't use the calculator quite a bit in the middle, but hopefully we got it right. Okay, so you want to round to the integer, so I'm gonna round this one up. Okay, regular rounding. So that's 26.67. So if I round to the integer, this round up. So this is approximately 27. All right, so that is using the formula in here. Okay. All right, number 14 here is if you can afford a monthly deposit of $120 into the account, paying 4.8% compound monthly, how long will it take to have $7,200 to buy a boat? Okay, as I mentioned earlier, since this is a monthly deposit, this is an annuity. Okay, because it's an equal payment. Okay, and then you have a 4.8% compound monthly. You want to find the time t in order to buy this one. I'm gonna show you how to use the calculator for this, okay? Because there's an app in the calculator, and I also want you to be able to use the app, make it much easier. So let's try the app. One thing is when you use the app, you have to know the character in the app because it's a little bit different than the formula, okay? If you go to the apps here, and there's one called Finance, and using the first one, TBM solver in here, okay? And now we will have to come back to solve this one. You have to get familiar with this one. The good news is when you use the app, you don't have to use the formula. This n here is the total number of the compound time. Okay, and we're gonna leave it that one for now, or you can just put a I'm gonna just put a 1 for now. Okay, we're gonna have to come back to solve this one because how long will it take? How long is the time t, right? And remember, if you want to find the time t, you have to have an n here equal to nt, and this n here in the calculator is this n. So we're gonna find the n here, and then we're gonna come back to find the t in here. Okay, so I'll show you how to do this one in the app. All right, so the good thing is the interest here is 4.8. You don't have to convert it into decimal point because we already have a percentage here. Present value, you don't have any money right now, so that is the 0, right? And you want to accumulate to That's your future value. So your future value is 7,200. And then you have a payment. Payment, we usually using the negative number because it's out of your pocket. So we have a payment of $120, and you're gonna pay it monthly. So this is payment per year is 12. Monthly is 12. Compound per year is also 12. And we're using the ordinary annuity, which is the one we have in this book. We all just using the annual and the ordinary annuity. That means the payment at the end of the month. So we're gonna do the payment this at the end. Okay, everything is already set up. We need to solve for n here. N is the unknown, right? So using alpha, enter is solve. The green one, alpha, enter. Look at it. I have an n here. It's 53.88. If I using the integer, my n here will be 54. Okay, so my n here is 54. And then we're gonna go to find the t. So t will be 54 divided by what? Since you compound monthly, so this will be actually that is 54 is run to the next integer. Total number of the month. We want to use in the month. We don't have to count the year. So that is the month. That is the month in here. 54 is the month. Okay, we don't have to convert it into year. So this is the month. 54 is the total number of the payment. Okay, and then total number of the payment we pay each month. So that's it. That's the answer. So what do you think about the app? I mean, it's a little bit learning curve, but basically it's faster, right? You don't have to take a logarithm in here. Okay, I will show you another one using the app in here. Okay, that way you can kind of get to know a little bit better. Find the I is the rate per period. N is the number of the period for the following loan at a given annual rate. So semi-annually payment of this much, making for 17 years to repay the loan at 6.5% compound semi-annually. How much is the I? Oh, we said that I is equal to R over M, right? So that's 0.0685 for this R. Semi-annually, M is 2, so we just divided by 2 in here. So that will give you 0.03425. So that is your R. And the N here is equal to MT. So you have a 17 years times T, M is 2, okay? So T is 17 years. It doesn't matter 17 times 2 or 2 times 17 is the same, right? So they're giving you 34, okay? All right, 2 more questions for tonight. This one, you want to find a payment. Remember the formula we have earlier. I'm not showing you how to use the app, or you can use the formula. If you do not like the app, you can use the formula. You can use this one. Okay, you can use the formula. This one using the formula isn't that bad because this you want to find a payment right here, so that should be really quick. So we have a 28418 equal to the payment, and then you have a 1 plus I already given you 0.029 to the n here is 89 minus 1 divided by I here is 0.029, right? So you're gonna go ahead and calculate this whole thing on the right hand side before you divide it by that, okay? So I can show you both way in here. We have a 1.029 because 1 plus this one is 1.029, right? To the power of 89 and then minus 1 and then divided by 0.029. So I will get the this one right here, I'm gonna keep 4 decimal point, 404 point 6242. Okay, I keep 4 decimal points, so that means it's very accurate. All right, so my payment here is just divided by this one, right? Okay, so that is not that bad to calculate this one. And if I don't like to type, I can just using the inverse multiply the 28418. Okay, so that will give you 70.23. Hold on, something not quite right. Okay, so let's double check in here. 28418, and then this is 1 plus I minus 1 divided by I. Okay, let's go ahead and double, because my answer is a little bit different. So we have a 1.029 to the power of n here is 89. Okay, minus 1 divided by 0.029. 404.62. Yeah, that's right. Okay, and then we're gonna use 28418. 28418 divided by, okay, so that's 70.23. Yeah. All right, so that means that is your payment in here, right? But you have to pay what? 89 times in this case. Okay. All right, number 17 in here is the e-loan online lending service. This is the last one. Recently offer 48 months auto loan at 5.4% compound monthly to applicants with good credit. If you have a good credit and can afford a monthly of $442, how much can you borrow from this e-loan? And what's the total interest where you pay for the loan? Okay, so what does this one mean? What does they ask for? 48 months, right? So 48 months, that means this is n is equal to 48 months. And if you want to look at the time, the year is 48 divided by 12, so that's 4 years. Okay, but you pick that monthly, so m here is 12, but you don't have to know this one because you already have that. All right. You have a payment. So you have a payment here is 442. Okay, and so that means what are we looking for? We're gonna looking for the how much loan you can borrow. So we are looking at a principal actually, so or the present value. All right. So this is trying to find the present value in here. Okay. And remember, we have this formula in here. All right, this is the future value, the present value, and the formula in here. Okay, so I can use this formula to do a calculation. I have a present value equal to the payment. So my payment here is 442, right? And then multiply, this one is 1 minus 1 plus I. I here, you need to calculate I here is R over M. Okay, and So this is R here is 0.054 compound monthly. Okay, so this one is already compound monthly in here. So we're gonna have I here is 0.054 in this case, okay? And then this will be negative n. N here is 48, okay? All right, so how do we calculate this one right here? You can put it in a calculator, but in order to calculate this one right here, you have to be very careful. I am going to put in a bracket in the numerator to calculate first, okay? So I like to calculate this whole bracket first. 1 minus parenthesis 1 plus 0.054 to the power of negative 48, you have to use the parenthesis, okay? And this is just my numerator. And then I'm gonna divide it by the denominator, 0.054, okay? I like to hit enter so I can calculate one step at a time. And then I'm going to multiply 442. So that will give you 7, okay, this interest rate seems a little bit low in here. All right, we're gonna using M is 12. We're gonna say this is the R, 5.5%. So we're gonna have I is equal to R over M instead. Okay, because that seems pretty low in here. All right, so the calculation is pretty much similar. We can just put this one in here. Just have to be very careful when I calculate the numerator. It's 1 minus parenthesis 1 plus, and then this to the negative power of, oh, so that's why I say I have to be very careful. I'm going to just calculate 1 plus 0.054 divided by 12 first, okay, inside the parenthesis first, and then to the power of negative 48 in here, okay, and then we are divided by this denominator also need another parenthesis, okay, and then so we have 4 and then multiply by 442. Okay. Okay, so run to 2 decimal point in here. All right, so that is the present value in this case. Okay, and how much will you pay in the interest? Well, if you so this is how much you can borrow, right? And you borrow this much, but you are paying 400. So total payment, we're gonna look at the total payment in here. Total payment. You pay $442 for how many times? For 48 months. Okay, let's see how much is the total payment in here. Okay, so this one, the number don't look, you know, okay, so that is the total payment in here, but this number don't looks like for some reason this number don't really match it that much. Okay, so let me go ahead and check. I mean, this is the calculation in here, but I want to check the number. This number don't look like a match that much, so I'm going to check the interest rate in here, and I will redo this question. I want to double check the interest rate in this case. Okay. But another way to do this one right here is I'm showing you the calculator. To do similar question is using the app. All right, so let's go ahead and using the app to see what happened in here. If you use the app, go to app, finance, using the TBM solver, right? So we can enter this whole thing. Like we have a 48 month, so this will be 48. Interest rate is 5.4%, right? And the present value is the one we're gonna come to solve. And the payment here is we said using the negative 442. Future value. Okay, I think this one is payment. Okay, I think it's missing something in here. Payment per year, that's per year, future value. That's why I think it's missing something. Present value. You don't have a present value. Okay, there's a little bit something in here. This question not quite clear. Okay, so basically, if you do the payment for future value, this should be the future value, right? And then if we let the future value as 0, and then find the present value. Okay, so that will give you 19,000 something like that. Okay, so that means after 48 months you want to pay it off. Okay, if you want to pay this one off in 48 months, you will have this much money you can borrow, $19,042.75. Okay, so for some reason that's why I like to using the app. This calculation somehow in the calculation didn't come out correctly. Okay, that's why the formula here is very hard to do that right. Using the app here is much easier. Okay, all right, so the app here we are giving you the answer directly right away, so you don't have to look at it. A lot of parentheses, even I can make a mistake in the formula calculation because it's so much detail. The total number of the payment here is 48 times, right? 48 months. You pay one time per month, so that's 48 times. Interest rate is 5.4%. And like I said, we don't want to owe anything after 48 months. Okay, so we're gonna have a future value as 0, and payment and compound per year is 12. So that means we can borrow this much, 98,042.75. We can borrow this much. Okay, and we already, so this is using the app. And how much you actually paying? Remember, if you pay $442 for 48 months, you actually paying this much. So this is still your total payment, right? and you borrow this much, this is your loan, okay? And how much is the interest? So the interest is using the total payment, using the total amount minus the principal, minus the present value. So we have a 21216 minus 19042, because assume this is how much you borrow, right? And let's see how much you paying for the interest. Okay, you paying for the interest is 21216 minus 19042.74. You borrow, you pay the interest is $2,173.25. That is your interest in payment. Okay, that is the interest in payment in here. So yeah, using the calculator, it is much easier using the app. So you don't have to go through all the negative power plus minus. That is a lot of calculation. I guess it's getting a little bit late, and then all this detailed calculation didn't come out correctly. Okay, so using the app is the good advantage in here. So showing you one more step. Go to apps, finance, right? And then using the first one, pick up the TBN solver, and then you just follow this one right here. The good news is when you use the app, you don't have to convert this one into decimal point, because this interest rate is in a percentage. All right, and the payment value, you just need to use the negative, otherwise your other value will come out negative. But we usually let the payment is negative. And then in order to solve this one right here, right? So in order to solve this one, you just hit, point the cursor right here, hit alpha, enter is the green one, is solve, alpha, enter. And then this one will pop up right there nicely, okay? So you don't have to go through all the negative power, the parentheses, fraction, okay? That's a lot of calculation in here. All right, so that's why I like to introduce this app for the annuity equal payment in here. And then if you want to solve for n, you can also solve for n. Just input everything else and alpha, enter. You can solve for n as well. Okay. All right. So we actually reviewed the 2 chapters today. I'm giving you the catch-up review for the chapter 2 and also review the chapter 3. So that's all we have for tonight. Okay, I know it's a little bit longer, so hopefully that helped. Any questions? Anyone has any questions?